Hi everyone. In this video I'm going to be going over a problem-solving strategy called cubes, and the problem that I'm using is related to the force of friction. So this is what cubes stands for, and the problem I'm working with says, what is the minimum horizontal force needed to start a 300 kilogram steel block on a steel table in motion? My first step is to circle numbers and units. There's only one here, 300 kilograms. My next step is to underline the unknown. That's the force. Sometimes at this point, I'm ready to list out my variables, but in this case, not really, because I don't know what type of force it is, and I also don't think that one number by itself is going to be enough to solve the problem. So I'm going to move on to box some keywords. I chose to box steel block and steel table because that makes me think of the approximate coefficients of friction table, and that helps me realize that I'm solving for a force of friction, and it also helps me realize what my coefficient of friction might be. Steel on steel means I'm choosing between these two numbers. I'm also going to box start, because if we're trying to start the object in motion, it hasn't actually started moving yet, meaning it's at rest, or it's static. So that helps me figure out that 0.74 is my value for the coefficient of friction. I'm ready to start listing out my variables now. I know that FF is my question mark, because that's what I'm solving for. Mu is 0.74, and remember that has no units. And I know that M is equal to 300 kilograms. That was just given to me. It's important to know your units and make sure that you know 300 kilograms is mass, and not get confused and think that it might be FG or weight. So M is 300 kilograms. It's time to pick an equation. I definitely need an equation that has FF in it. So I'll scroll to the last page of my reference table, and this is what I see. FF equals mu Fn. If you want to spend some time going through that, you'll see that that's the only formula with FF. So I don't really have much of a choice. Although I am going to run into a problem here because I don't know what Fn is equal to. I know that it stands for normal force, but what am I going to plug in for the normal force? So it's my job to remember that Fn is the same as Fg when the object is on a horizontal surface. Fg points down, and it's equal to Fn that's pointing up. These are going to be balanced if the object is sitting or sliding or being pushed. Anything on this horizontal surface, they'll be equal. So I decided to find a formula to solve for Fg. This is what I found in my reference table. And since I'm solving for Fg, I want to rearrange it. I put that into this pyramid, so Fg is in the top of the fraction, so it goes in the top of the pyramid. And that helps me rearrange my formula so that it says Fg equals Gm. If you wrote Fg equals Mg, that's the exact same thing. It's totally fine. So one way that I could solve this problem is first solve for the force of gravity, and then plug that into my friction equation as Fn. But I want to show you another way to solve the problem, which is actually combining two equations. So once we know that Fg equals Gm, we also know that Fn is equal to Gm. My normal force, because it's equal to gravity, I can just use Gm to show my normal force. And what that means is, if I go back to my original equation, if Ff equals mu Fn, then I can just take out Fn and replace it with Gm. Because if they're really the same thing, then it shouldn't matter which one I use. I should just use whichever one's easier for me in this particular problem. So now I've constructed a brand new equation that actually is going to be easier for me to use, and this may save me a step or two since I don't have to solve two different equations. I can combine them into one and then just do it all at once. So I finally picked the equation I'm going to use. I can't forget that I should still be listing out all of the variables I'm using, so I should also list out lowercase g. G is 9.81 meters per second squared, and I found that on the first page of my reference table. All the way at the top, acceleration due to gravity, g, is 9.81 meters per second squared. So I've got all my variables listed. Now I'm just ready to plug it into the equation. so it's time to solve. FF equals 0.74 times 9.81 times 300. I plug that into my calculator and I get FF equals 2,177.82 newtons. You can round that because it's a multiple choice question. The answer that you're choosing is 2,220 newtons.